Hey, still being blinded kind of by the sun, but we're gonna make another video. So for this video, it's still problem solving. It's problem solving with like direct translation, but it's gonna have a specific geometric feel to it. Okay, so we're gonna talk about supplementary angles, complementary angles, and triangles in these problems. Okay, the setup's gonna be just like those problems we did with just problem solving with direct translation or the consecutive integers. It's a similar setup, but just we've got some definitions we need to know is the only difference. Okay, so a few things that you do need to know about these problems. So we've got problem solving with geometry. Some of these problems use formulas. We'll do those second. They're a little bit tougher. Some use definitions. All right, we're going to start with the definitions. I think they're a little bit more clear. They're going to follow the exact same setup that we did with problem solving with direct translation and consecutive integers. The ones where you use formulas, little different, okay? So they're not really harder, there's just kind of extra steps involved, all right? So the definitions that you need to know, and you may already know them. The first thing you need to know is what are complementary angles? These are two angles whose sum is 90 degrees. So any two angles, if you add them up and they equal 90 degrees, those two angles are considered complementary angles. We also have supplementary angles. And these are two angles whose sum is 180 degrees. All right, so if you have any two angles that add up to be 180 degrees, those two angles are supplementary angles or supplements of one another. The third thing you need to know is kind of more fact than definition, but the three angles of a triangle must add up to 180 degrees. All right, so that probably came up back in unit 7 in tier 1 with geometry. All right, so complementary angles, two angles whose sum is 90 degrees, those two angles would be considered complements of each other. Supplementary angles, any two angles whose sum is 180 degrees, and then the three angles of a triangle must add up to 180. So let's look at a couple of examples of direct translation problems involving geometry. All right, first up, find two complementary angles such that the larger angle is 10 degrees more than, let me write out words, than 3 times the smaller angle. All right, so we know we're finding two complementary angles. That means we're looking for two angles who, when you add them up, they would equal 90 degrees. We have a larger angle that is 10 degrees more than 3 times the smaller angle. So I start with words. I know if I take the larger angle, add it to the smaller angle, they have to equal 90 degrees because we're dealing with complementary angles here. All right, so larger plus smaller must equal 90. All right, so now's the time where we do that direct translation thing where we go back to the problem, we look for a hint about one of these two angles. Whichever angle we have a hint for is not going to be the variable. The angle that we don't have a hint about is the one we're going to assign the variable x to. So I know that the larger angle is 10 degrees more than 3 times the smaller angle. That means I know something about the larger angle. I don't know anything about the smaller angle, so I'm going to go ahead and call the smaller angle x. So of the 90 degrees that we have available to us, x of them are going to go to the smaller angle. Now, for the larger angle, we want 10 more than 3 times the smaller angle. So 3 times the smaller angle is going to be 3x, and then I need 10 more than that. So the larger angle, we can call it 10x or 3x plus 10. All right. So what we want to do now is combine like terms. So 3x plus 1x is 4x. There's nothing to combine with my 10, so I just bring it down. All right. And what we have here, this line right here, this is the equation that we need to solve. If we can solve this equation for x, we'll know the value of the smaller angle. We use that information to get the value of the larger angle. We check to make sure everything adds up all right, and then we answer the question out formally. So first thing I want to do is get my 4x's by themselves. So I subtract 10. 90 minus 10 is 80. And then the 10's on the right cancel, leaving me with just a 4x. All right, now I need to undo the multiplication of 4 and x. So I would divide. The 4's on the right cancel, leaving just an x. And then 80 divided by 4 is 20. This tells me that the smaller angle is 20 degrees. Okay, so we want to double check the larger angle. So we want to take 3 times the smaller angle of 20. We want to add 10. Well, 3 times 20 is 60, right? And then if I add 10, that's 70. So I have degrees of 70 and 20. Let's add them up, make sure it adds up to 90. It does. Everything checks out beautifully. We could say something simple like the angles are 70 degrees and 20 degrees. So remember from the previous videos, once you solve for x, you're not done. You got to answer the question. Find 2 complementary angles, all right? So we've got to make sure we have answers for 2 complementary angles, and then never assume your reader is a mathematician. Always pretend you're doing a presentation for a group of non-math people where the work isn't going to make sense. They're just interested in the final answer. So always write out your final answer, all right? Let's try another one. This one I think is actually even a little easier. Here we're going to find 2 supplementary angles such that the smaller angle is 30 degrees less than the larger angle. Okay, so in this particular problem, you need to make note of the fact that we're dealing with supplementary angles. We know from earlier that supplementary angles are 2 angles that add up to 180 degrees. All right, we're dealing with a smaller angle and a larger angle. So starting with just words, I have a larger angle. If I add it to my smaller angle, it has to add up to 180 degrees. Okay, supplementary angles must add up to 180. So what we want to do now is do the direct translation part. So here's where we go back and we figure out the algebra, we assign a variable, and you always want to assign a variable to whatever piece in the problem you don't know anything about. So if we go back and read the question, find 2 supplementary angles such that the smaller angle is 30 less than the larger. That means we know something about the smaller angle. So we're going to go ahead and just say, okay, we don't know anything about the larger angle, we're going to call it x. And then using that value for x, we're going to write an expression for the smaller angle. We know the smaller angle is x, but with 30 taken away from that, so it's going to be x minus 30. All right, so you've done the direct translation part. At this point, you would combine like terms. So x plus x is 2x. There's nothing to combine with my minus 30, so I'm just going to bring it down. All right, so at this point, this right here is the equation that you want to solve. All right, first step is to isolate the variable that contains, or the term that contains the variable. So we want to isolate 2x. I do that by adding 30 to both sides. Let's see, 180 plus 30 is what, 210? So 210 is going to equal 2x. The 30s have canceled. All right, and at this point, I want to undo the multiplication of my 2 and my x. So I divide by 2. The 2's cancel, that leaves me with 1x, and 210 divided by 2 is 105. Now, we're not done. we have to go back and answer the question that's being asked. The question tells us to find two supplementary angles. At this point, we just have one angle. And the angle that we have right now is the larger angle, which is x. Now, the smaller angle we knew was x, which is 105, but we want to subtract 30. So 105 minus 30 is 75. So it looks like right now our two angles are probably going to be 105 and 75, but let's add them up. Let's make sure it adds up to 180. So 5 and 5 is 10. Keep a 0, carry a 1. 1 plus 0 plus 7 is 8. Drop down your 1. Everything checks out. So at this point, you've answered the question. You've checked your work. Write out your final answer formally. The angles are 105 degrees and 75 degrees. And that's it. Okay, so supplementary and complementary angles are pretty easy. When you're dealing with triangles, it's not that they're hard, but you do have an extra step. So let's look at a triangle problem. So here we're going to find the three angles of a triangle such that the smallest angle is 60 degrees less than the largest angle, and the middle angle is 15 degrees more than the smallest angle. All right, so we've got three angles of a triangle. They're calling them smallest, middle, and large. And so what we should know at this point is if I take the smallest, the middle angle, and the largest angle, add them up, I have to get 180 degrees. So we're going to go small, middle, large. Add those together, and we get 180 degrees. Okay? Now, at this point, we've got three pieces to this problem. We want to go back and find hints about two of them. The angle that we don't really have any hints about, we'll call it the variable x. All right. Sorry, I'm drinking water in between. I haven't talked this much in a while. All right. So the smallest angle we know is 60 degrees less than the largest angle. That means the smallest angle is not going to be our variable. We also know that the middle angle is 15 more than the smallest. We've got a hint about the middle angle. It's not going to be the variable. The one that we don't really have any information about, we're going to call it x, which is the largest angle. Now, given that the largest angle is x, let's answer the questions about the smallest angle and the middle angle. So if we go back to the smallest angle, we're told that the smallest angle is 60 degrees less than the largest angle. So the smallest angle is going to be x, but then minus 60. Okay. Now, the middle angle you got to be a little careful with. We haven't seen anything exactly like this so far. They kind of take the middle angle and refer it back to the smallest angle, not the largest angle. So here it says the middle angle is 15 degrees more than the smallest angle. So we get the middle angle is the smallest angle plus 15 more. Okay. So when you combine like terms here, you might want to be a little bit careful. In fact, I'm going to scoot over and I'm going to clean this up a little bit. So the smallest angle is still x minus 60. The middle angle is x minus 60, but then I want to add 15. So minus 60 plus 15 is minus 45. And the large angle is still just plain old x. Everything still has to add up to 180. Okay, so let's go ahead and combine like terms in the second column that I have going. If I take x plus x plus x, I get 3x, right? And then negative 60 minus 45 is negative 105, okay? So at this point, we've got an equation right here. This is what we want to solve. All right, first step is to isolate the term that contains the variable. So to do that, I'm going to add 105. 105's cancel. I get 285 equals 3x. And now what we want to do is we want to undo the multiplication of 3 and x. So to do that, I would divide by 3. 3's cancel, and I'm left with x is equal to 95. Now, we're certainly not done. We know that x represents the largest angle, so we can say over here, okay, x is 95 degrees. The middle angle after we simplified is going to be x, which is 95 minus 45. So the middle angle should be 50 degrees. The smallest angle is x, which is 95 minus 60. So the smallest angle should be 35, but we definitely want to add this up and check. So 5 plus 0 plus 5 is 10. So I keep a 0, I carry a 1. 9 plus 5 is 14. 14 plus 3 is 17. 17 plus 1 is 18. Everything checks out. And don't forget to write a quick statement about your answer. The angles are 95 degrees, 50 degrees, and 35 degrees. All right, again, start out in words like we did right here. Do your direct translation and simplify like we did here. Solve your equation like we did here in this third part. Once you're done and you have a value for x, you're not done with the problem, you're just done with the algebra. Go back and answer the question. Find the 3 angles of a triangle. We did that here, we checked our work, and then we wrote out our final answer. Be thorough. Math students are notorious for not being thorough, okay? Be neat, be organized, be clean with your work, show your steps, and finish out the entire problem. All right? All right, let's see if I've got one more. The last type of problem I want to do is where we use a formula. So using formulas. So this is kind of like combining what we just did with what we did earlier in one of the videos in the series where we used a formula. So what we have to do is we still have to set up a problem where we use direct translation, but the algebraic expressions that we create using direct translation then get plugged into a formula, and that formula with these expressions plugged into it become the equation that you solve. And then once we're done, we kind of go back to the direct translation, make sure we have values for each piece of the problem, and then we check our work, okay? So, little different. So we use direct translation. To create expressions for the different, we'll call them dimensions in the problem. So if you're dealing with a perimeter problem, perimeter problems involve perimeter, length, and width. So you're going to use direct translation to come up with expressions for those. We're then going to take those direct translation expressions, plug them back into the formula, and solve. So take these expressions, plug them into the formula, and solve. And then we want to go back and check our work and answer the question. The only thing that I think makes these a little bit harder is they end up naturally being just a tiny bit more messy because they have a little extra going on. But otherwise, they're really not too bad. So let's take a look at one. The length of a rectangle is 2 inches more than twice its width. All right. And then we go on to say if the perimeter is 52 inches, what are the dimensions of the rectangle? There are lots of ways to set these problems up. Some people draw a picture, so they'll draw a rectangle and then they'll kind of have an area, they'll have a place where they label the length and the width and then convert that to algebra. Some people just kind of do it without a picture. It's up to you. Do what works for you. One thing I would caution you on with these problems, a lot of times when we assign variables, we're prone to assign variables that kind of fit what we're dealing with. So like a lot of times if you have a problem that involves cost, you'll let cost be C instead of like an X or a Y. I would encourage you to use different variables here because it will get kind of messy and it's easy to get them mixed up. Okay, so we know that we need perimeter, length, and width. We also know that the formula for perimeter, and if you don't know this, here you are. The perimeter formula is 2 times the length plus 2 times the width. Okay, if you have forgotten some of these formulas, don't forget you have a formula chart in Moodle. All right, now in this problem we are told flat out that the perimeter is 52 inches. Okay, now the length and the width, this is where the direct translation is going to come into play. The length of a rectangle is 2 inches more than twice its width. Okay, we know something about the length, so when we assign the variable, we always want to assign the variable to what we don't know. We don't know anything about the width. So instead of using a W here, which I know is tempting, I'm going to use a completely different variable. I'm going to call it X. Okay, now go back to the length. Using the idea that width is X, create an expression for the length. So the length of the rectangle is 2 inches more than twice the width. So twice the width is 2x, and then we want 2 inches more than that. This stuff right here, we're going to plug in right here. Okay, so we know that perimeter is 52, and it's equal to 2 times the length, and the length here is 2x plus 2, plus 2 times the width, and here the width is just x. So this right here, this is the equation we want to solve. And when we solve, we'll get a value for x. Remember, x is your width. And then we use that to figure out what the length is. So let's simplify. I get 52 equals, well, I need to distribute initially. So 2 times 2x is 4x. And then 2 times 2 is 4. And then over here, 2 times x is just 2x. It's another water break. All right. So I get 52 equals, well, I need to combine like terms. 4x and 2x can be combined to be 6x. And then I still have my plus 4. All right. So I need to isolate the variable or the term that contains the variable. So I want to subtract 4 from both sides. That gives me 48 equals 6x. The 4 is canceled on the right. And then I need to undo the multiplication of 6 and x. So I divide everything by 6. The 6 is canceled, and I am left with x equals 8. All right, and just don't forget, x was the width. All right, so I'm going to have to go to the next screen. We can refer back to this one in a second if we need to. So a few things to remind ourselves of. Perimeter is 2 times the length plus 2 times the width. We knew the perimeter. It was given to us as 52. The length was 2 times the width plus 2. The width we decided was just x. And now we have that x equals 8. All right. So then if I take 2x and I add 2, which remember, that's just my length right here, I would get 2 times 8 plus 2. So I would get 16 plus 2, or 18. So the length is, remember, 2x plus 2, or 18 inches. The width was just x, or 8 inches. And so now we want to just check our work really quickly. So what we're going to do is we're going to take 18 for L, 8 for W, and P, we already are given as 52. So does 52 equal 2 times the length of 18 plus 2 times the width of 8? Well, let's see. 2 times 18 is 36. 2 times 8 is 16. Turns out 32 plus 6, or 36 plus 16 is in fact 52. So everything checks out, and this is the final answer. So the length is 18 inches. Let me write that out. And the width is 8 inches. And there you have it. So I do think these problems are a little messier, but you basically figure out the length and the width, or whatever the dimensions for the particular problem are, using direct translation. You plug all the information in for all the different variables in the formula back into the formula. You solve, and then you answer the question that was asked. Okay? So that's just a really quick overview of direct translation with geometry. You don't really get too deep into the weird geometric formulas at this point. You will definitely see complementary and supplementary angles, angles of a triangle. You could see perimeter. I think that's it. I don't think there's anything else you would see as far as the geometry. So this video is a decent overview of that. Remember, like I said in all the other videos, join Zoom, okay? We're on Zoom every day that we're supposed to be in class, okay? And we sit there and hope that you all will come and ask us questions. So if you're struggling with anything, really make time to come visit us on Zoom. We can help you. We're all mathematicians, okay? That's what we do for a living. So we love to talk about math. We love to help you, okay? So join Zoom, come with questions. Remember, it's really difficult if you're like, I'm just having a hard time with everything, okay? That's not very helpful. It's very helpful if you're like, you know, I'm in Unit 9 right now and I'm really struggling with the uniform motion problems, or I'm really struggling with the consecutive integers, okay? Be very specific, and it's even better if you can come with specific questions that you're struggling with. So have Zoom up, not have Zoom, have Ed Ready up so you can share your screen and show us particular problems, or take screenshots of problems and email them to us, and then when you finally meet with us on Zoom, we can help you out. Obviously, a lot of you have kids at home, and if you've got to do your homework at night after you get your kids in bed, I get it. But really make the most of those Zoom meetings, because we're all there and we all want to help, okay? Hopefully these videos are helping. I'm going to look into seeing if I need to make one more. All right? If you need anything else, just let us know. Thanks.